No long explanations, no unnecessary theory, just pure AI coding in Python. In this video, we're going to build and fine-tune a text generation model using Hugging Face transformers, all in a Python notebook, in under 10 minutes. So what is text generation? Hugging Face, the most popular AI platform for NLP, defines it as generating text is the task of generating new text given another text. These models can, for example, fill in incomplete text or paraphrase. This means that models can complete sentences, summarize text, and even write stories. For example, in this illustration, you can see how an AI model predicts the next words based on an input text. Here, the input is "once upon a time," and the model completes it with "we knew that our ancestors were on the verge of extinction," similar to how popular chatbots like ChatGPT operate. Now, let's explore some of the text generation models available on Hugging Face. You'll see well-known models like GPT-2, Llama, Mistral, and the latest one, DeepSeek, each optimized in its own way. For this tutorial, we'll be using the DeepSeek R1-DistillQuinn 1.5b version, a lighter variant of a powerful AI model. With just 1.5 billion parameters, it's easier to fine-tune and runs faster on consumer hardware. Now, let's open Google Colab and walk through the code. In part 1, we'll set up our environment and run a text generation model using Hugging Face transformers. Before we begin coding, let's make sure our runtime is optimized. First, change your Colab runtime to GPU, ideally with a high amount of RAM. This ensures you have the computational power needed for our text generation model. Next, we install the Hugging Face transformers library using pip install transformers. This library gives us access to a wide range of pre-trained NLP models. After installing, we need to set up secure access to Hugging Face. Head over to the Hugging Face website, navigate to your account's access tokens section, and create a new token. Choose a descriptive name and select the necessary privileges. Then add this token to your Colab secrets as HF token. Now, let's import the pipeline function from the transformers library and define our text generation pipeline. We specify our task as text generation and our model as DeepSeek R1-DistillQuinn 1.5b, a lighter version of a powerful model. Our prompt for this demo is, explain how neural networks work in simple terms. When we call the generator function from the pipeline, we use 4 key parameters: our prompt, max length, truncation, and number of return sequences. Here, max length defines the maximum number of tokens in the generated text. The truncation parameter ensures that if the output exceeds this limit, it's cut off properly. And number of return sequences specifies how many different text outputs we want to generate from our prompt. With everything set, we run the pipeline, extract the generated text from the first element of the results, since we set number of return sequences to 1, and print the generated text. Let's run the code and see the output. It will take some time, so I will pause and come back when it's done. And here you can see the generated text. If you want to know why we use the generated text key, check what the result variable contains. As you can see, we receive just one element, and our generated text is defined by the key generated text. This completes our inference setup and gives us a taste of how text generation works using a Hugging Face model. Now that we've tested the Hugging Face model for text generation, let's fine-tune it on our own dataset. Instead of using it as is, we'll train it with custom AI-related data to make it more relevant for our specific use case. First, We installed the required libraries, transformers for handling the model, datasets for managing training data, and weights and biases for tracking progress. Then we import everything we need. From transformers, we bring in classes like Auto-Tokenizer, Auto-Model for Causal LM, and Trainer. From datasets, we import dataset to handle our data. Next, we grab our weights and biases API key from its website and store it in our Colab secrets, which keeps things secure. Once that's done, we can log in with something like this, and we're good to go. Here's our custom dataset. It's relatively small for demonstration purposes, containing 4 examples in the training set and 2 in the validation set. For real-world applications, you should aim to use a significantly larger dataset to train the model effectively and ensure better learning outcomes. Now we load our tokenizer, the same one used by the pre-trained DeepSeek model. The tokenizer converts text into numerical tokens so the model can process it. If the tokenizer doesn't have a padding token, we assign the EOS token as the pad token. Then we load the model itself. Next, we turn our data dictionaries into Hugging Face datasets, which helps us store and manage them efficiently. We define max length equals 64 to ensure each training example has no more than 64 tokens. We also define a tokenize function that truncates and pads each sequence to a max length. Then we call the map method on both the training and validation sets to apply this function. This way, every example is uniformly prepared for training. And add labels by copying input IDs. The labels are simply the input IDs because the model learns to predict the next token. Now let's configure our fine-tuning process. In training arguments, we define some key settings. Output dir, where we'll save model checkpoints, learning rate, how quickly the model updates weights, batch sizes, how many examples we process each step for training or evaluation. Evaluation strategy controls how often we evaluate the model, number of train epochs, how many times we'll cycle through our training set. Evaluation steps, logging steps, and save steps control how often we track progress and save checkpoints. Load best model at end ensures we keep the best performing version. Report to directs logs to weights and biases during training. Push to hub if you want to upload your finished model to the Hugging Face hub. Then we set up the trainer, providing it with our model, tokenized datasets, and these arguments. Now we start fine-tuning by calling trainer.train. This runs multiple training steps where the model learns from our custom dataset. Thanks to weights and biases, we can track real-time training metrics like loss values and evaluation performance. This helps us understand how well the model is adapting. Training will take some time, so I'll pause and come back later. Once training is done, we can check the results here or on the Weights and Biases website. We also have the checkpoints saved here. And finally, the model is on the Hugging Face website for later use or to share with colleagues or friends. Since our dataset is very small, the output might not change significantly. However, if we were working with a much larger dataset, fine-tuning would lead to more noticeable improvements. The more relevant data we train on, the better the model adapts. Now that our fine-tuned model is ready, let's go back to our original text generation code and swap out the DeepSeek model for our newly trained version. Now, let's run the same prompt and see how the fine-tuned model responds. As expected, with our small dataset, the output might not be drastically different. However, if we had trained with thousands of high-quality examples, the fine-tuned model would generate much more specific and relevant responses. And that's it. If you found this useful, make sure to like, subscribe, and check out the Colab link for the full code in the description below. Let me know in the comments if you want more tutorials. See you in the next one.